again. I'm just trying to keep the size down for YouTube. Is it running? So let's go back to that 1K on that resistor, 1K on this resistor. Expected output, half the size of the input, right? What happens, because we're running at 60 Hertz here now, what happens if I double click on the AC signal source and now I put, well, it's not the best way to do it, so let's just put 1M for 1 million Hertz. Okay? What do you think is going to happen if I run it now? So I was running at 60 Hertz before and now I'm running at a megahertz. Yeah, good answer. It's going to go up and down quicker. Is the amplitude going to change? Why should it? Because it's a resistor and it's not reacting. So let's probably have to change the scale on there to be able to see it, but the gentleman over there wiggling his fingers up and down, there it is, look, it's going up and down so fast that actually we can't see anything at all because I'm on the old scale, so it's just blocking out the oscilloscope because it's sampling too slowly. So what I can do is I can change the sampling frequency. So here, if I click on this now, look, 20 milliseconds? No, that's the wrong way, isn't it? I want to sample more often. Now look what starts to happen. So as I sample more and more and more often, look what we've got now. So that's particularly sampling very well, isn't it? But you can kind of see that now I can see that waveform. Because all I'm doing is what I said in that original one, where the oscilloscope is looking at one point in time, waiting a little while, looking at another point in time, waiting a little while, looking at another point in time, and that's how it all gets on afterwards. And if we're on the wrong time base, which we were before, then we don't see anything at all. We just see. And you see as I zoom in further and further and further, so I look in more and more and more detail all the time, I start to see finer and finer parts of the wave. And as I look less and less and less often, you start to see that you can see nothing. And there's kind of something which is intriguing with this and could well be related to quantum mechanics, because if you don't look at the right time, you don't have any information. And this will appear to be showing you something quite similar to that, but that's quite philosophical. Right, so there you have it. So what I want you to do is I want you to play with the ratio of those two resistors, and I want you to play with the frequency so that you get good at using that oscilloscope. Because there's two things you need to drive an oscilloscope, two main things: your time base, which on these scopes is over on the right hand side here, and your amplitude. Now if we get the amplitude wrong, so let's use that as an example. So I'm just going to, I'll leave it on the same frequency. But if I get the amplitude wrong, look what happens. So I'm 2 volts per division. I'm only working on the big wave, by the way. Let's do both at the same time. So I'm on 500 millivolts per division, half a volt per division. Nothing. All I can see is some vertical lines. So my amplitude is wrong on the oscilloscope. So I need to adjust that a little bit. 2 volts up. So on 5 volts I can see it, on 10 volts I can see it. Make sure both of them are on the same scale. And then lo and behold, you can use an oscilloscope. What's good about an oscilloscope? You can see electric, basically. It's probably the most useful tool I think I've ever learned after I finished my high school education. You can see electricity, that's great. Because if you can can see it, you can do something with it. Can't see it. I mean, how am I going to see something that's running at 1,000,000 times a second? Can't see it, right? But using one of these, you can. And doing it in simulation, you can as well. So it just opens up a whole series of doors, which kind of makes anything possible. So play with those ratios, play with the amplitudes, which is one and the same thing. Make sure you can use that oscilloscope. It's really important for what comes next, okay? Okay, give you about 10 minutes on that. Any problems, hands in the air. Shout loud and proud, we don't care, and we'll help you in any way we can. Okay?